Thank you for joining The Right Dose. We will take a trip through the science behind pesticide use in Florida agriculture.
Our goal is to educate pesticide applicators and the public in the critical areas of integrated pest management according to Florida regulations.
So, sit back, relax, and put your learning hat on as we discuss the right dose and how we can positively impact our environment, our economy, and our communities.
Welcome back to another episode of The Right Dose. Today we're going to go back to our book, Applying Pesticides Correctly, and study Chapter 5. So Chapter 5 is about pesticides and the environment. Anything that we do as pesticide applicators can have a repercussion that may affect our neighbor, the environment around the farm, and also our bodies. So we want to properly dispose and apply pesticides according to that label, because that label has research-based information of the effects of these pesticides that we are applying, right? And that environment we want to protect as much as we can. We have water bodies around the farm. We have air quality that can be affected. We have peers that work in the farm with us that can also be affected. So that's our environment. We have to think about it as a whole. We do not need to be thinking about applying pesticides as a task, but as our potential impact to the environment. So today we have again Ajia, multi-county citrus agent from RD, DeSoto, Manatee, and that's it, right?
That's it.
We also have Luis, our small farms agent and pesticide licensing agent in Polk County, and Lourdes, which is our Highlands County agriculture agent. So let's jump in the topics of discussion. First of all, let's talk about the environment. What constitutes that environment that we are interacting with?
Yeah, so basically the environment is everything that is around us. Usually we think that the environment is just like the natural world and everything that we enjoy outside, but it can also be the place where we're at inside and indoors. So some of the elements that are included in the environment are water, air, soil, plants, animals, and buildings, because again, it's outside and inside as well.
And with farming and with agriculture, we have also to think about microbiome in the soil. So we have a lot of microscopic organisms that live in the soil, and our pesticide applications can affect them. We can also mention the water bodies and the effect of runoff, pesticide runoff in our water bodies, etc. So again, back to the introduction. This is complicated. It gets complicated, and we want to have a good reputation as pesticide applicators, because farmers are essential to the economy of the United States, and we usually find that we are portrayed as the agricultural community as polluters, as mismanagers. So we want to change that, and you as a pesticide applicator have a direct impact in that reputation. So let's continue with the topics here. What is a non-point source pollution? These are things that are in the book. Can you guys help me define what a non-point source pollution terminology means?
Yeah, so a non-point source pollution is pollution that you cannot track, right? So you have on the other side a point source, which is a spill, for example, that you can track and you know exactly where it comes from. That's not the case with the non-source point.
So again, we go back to our environment. There's a subdivision, and there's 37 different pesticide applicators that are servicing all the community. This is a 500 unit community. So each of the owners are applying pesticides are applying fertilizer by different companies. So it is going to be very difficult for them to source who is the culprit for mishandling applications that result in a fish kill, for example.
Right.
So that's elaborating on that example. What are the characteristics of a pesticide?
So we have four characteristics of pesticides. The first one is solubility. Then we have absorption with a D, not with a B. Then we have persistence, and then we have volatility. So I'm gonna be talking about the first two. So the solubility of a pesticide is the ability for that pesticide to dissolve in water. The more soluble the pesticide, the more contamination it can create, because it's going to be very hard in order to remove it from that water source if it actually reach that water source.
So more soluble means potentially more dangerous to the environment.
In a way, yes, because it will basically dissolve more easily in water, and that means it will be very difficult in order to remove it from that water body.
Yeah. So and to be clear, that does not have to do anything with toxicity.
No.
Yeah. Okay. Awesome. Absorption now.
So absorption is the ability of that pesticide to add itself into soil particles. So basically, the more absorbent can be that pesticide, the more it will attach into these soil particles, and that is good and bad at the same time. It's good because that means that pesticide will remain in the soil and won't go down into that groundwater. But it's bad because if you want that pesticide to have a good effectiveness, you don't want to have that pesticide get into those particles. You want that pesticide to actually spread around and do its effective effect to that pest. So it's a good thing or a bad thing. But I say at the end of the day, we're talking today about helping the environment, and the more absorbent that pesticide may be, the less harmful it's going to be to the environment.
Okay, so the less likely it is to move from the application sites, the target, into our water bodies, into the air, etc.
Exactly.
Awesome. All right, persistence and volatility. Define those for me, Ajia.
Okay, so persistence is going to be basically the length of the time that a pesticide remains active in the environment before degrading. So when you hear about a pesticide being persistent, that means basically it sticks around for a long time. And those are different lengths. That's actually measured in a half-life as far as how persistent a pesticide is. Different ways that it is degraded in the environment is going to be through photodegradation, which is going to be exposure to sunlight, water degradation, which would mean it would break down with moisture or rainfall, that sort of thing. And then also microbial action in the soil can break down a pesticide.
So with persistence, we're talking about half-life of that pesticide, which is a term that we use in science. Comparing two pesticides, glyphosate versus an aminopyrrolide, the glyphosate has like a breakdown time of like 14 days versus an aminopyrrolide, which it can persist for 6 months to 2 years. This is just an example. Those are not real numbers, but so you can have a comparison of different persistence rates, basically.
Correct, exactly. So, and again, that's kind of like what Luis was talking about. You want something to be persistent enough to have a good effect on the pest that you're trying to control, but you don't want it to be persistent to the point to where it is polluting the environment. Yes. Correct. Okay, the last characteristic that I was going to mention is volatility, and that is the potential of a pesticide to turn into a gas or a vapor after application. And this is important to know because that can be temperature and wind dependent, the volatilization of a pesticide, meaning you can have the temperature affect how maybe quickly that happens, and then if you have wind, if there is a large amount of those vapors or gas present, we could end up with vapor drift, where it could go into a non-target area and not stay in the site where you did apply the pesticide.
Hence, probably affecting another person's crop or rose bushes, etc.
Correct, and there can also be an inhalation risk with that as well for any bystanders.
Applicator as well.
Yes,
yeah.
or an applicator, sure.
So if we read the label, will we find more information on this four aspects of the pesticide?
Correct. Some of the labels will actually tell you how soluble will that pesticide will be, or how volatile that pesticide will be as well.
Okay, so let's talk about drift. What is drift, and a little bit more on how it happens, etc.
So yeah, drift is basically defined as the unintentional move of pesticide particles into a non-target area. In another explanation, I am applying into my crops, and for some reason, this pesticide instead of remaining to my crop, it reaches another place, like a park, another house, or something like that, or another people's crops that may be harmful for them. It's always good to know that there's always gonna be some kind of drift. It's very difficult to basically have 100% no drift, so some kind of vapor drift is always going to be happening. What we want as pesticide applicators is to minimize the potential of drift using the correct equipment, using the correct calibration, and so on. So the first drift is spray drift, is the most common because most of the pesticides are applied as sprays. So what affects the spray drift, as Ajia just mentioned, is wind condition, which is always going to be affecting drift. If I know that there's very windy conditions, I should always avoid to apply my pesticide with that because basically that wind condition can move around my pesticide. And the other important thing in pesticide is going to be that droplet size. Larger droplet size will minimize drift. Smaller droplet size is going to increase drift, and this is because of the weight of that
Droplet.
the droplets. Yeah. So largest droplets weigh more than they reach the ground more faster than smaller droplets, which are gonna stay in the air longer times.
So more pressure in the sprayer means smaller droplets and more potential for drift.
Exactly. And another thing that we can actually use is that boom height of our spraying equipment. The higher that boom height, the more pesticide drift we can actually create. So if we can, because not always is possible, but if we can reach that boom height, the more closer to the ground, the better to minimize that pesticide drift. The other one is vapor drift, which Ajia already spoke a little about it, but just to mention, again, windy conditions are gonna increase that vapor drift, but also that temperature. Higher temperatures will cause more vapor drift. And then we got also what is particle drift, which is basically whenever we use some kind of solid pesticide like granules, especially dust, for example, those windy conditions can basically move those pesticides into our non-target area. So basically, again, drift is just the unintentional movement of particles into a non-target area.
So how do we control drift? What are those strategies that we have to utilize to control drift, like looking at the weather?
Yes.
Or,
Again, as I just said, never apply pesticide when we have bad climate conditions, like very windy conditions. Also, it's very important to always calibrate your equipment correctly in order to minimize that drift. And as I said, make sure about that boom height. Make sure that you, whenever you can, just lower that boom height as closer to the ground as possible. And then, as always, follow your label. It's very important to always follow this label because this label is going to let you know what's the application rate that you need to use in order to avoid some kind of drift.
And with pesticide spray drift as the main poster child for drift, I guess, when you apply that pesticide early in the morning, when there's no potential for wind, when you get that job done early in the morning, there's a better chance that you're going to have a successful application. Does drift affect the effectiveness of that application? Because it's removing some of that pesticide away from the target.
In a way, yes. Basically, let's just think of I have 100% of my pesticide. For some reason, 20% of my pesticide is moved out by wind. So basically, I only applying 80% of my pesticide, and that 20% of my pesticide just go away. So basically, that is lowering the effectiveness, or that active ingredient that I'm applying basically it messes up the rate of the pesticide I'm applying.
Okay, in Florida, moving on with the next objective. In Florida, we're known for having a lot of lakes and first magnitude springs, etc. There's a lot of water, and that's one of the beauties of being here. So the folks that are in other states or countries, you gotta come and visit us and enjoy more than Disney World. Okay, just bragging here for a second. Why do we have to take surface and groundwater into account in this equation? And can we talk a little bit about surface water versus groundwater?
Sure. So surface water, like Jonah said, we have a lot of that here in Florida. So whenever we're having an agricultural establishment, it's good for the applicator to understand what those surface water areas may be, whether that's a lake or in the Flatwoods area here in Florida, that's going to be ditches, canals, swells, that sort of thing for drainage. 38% of our freshwater use comes from surface waters in the state of Florida that we use as a population. So it's really important not only for the environment, for us as well, to keep those areas as clean as possible. And one way of surface waters becoming contaminated is going to be from runoff. So if we have, say, a pesticide application that we do, and then all of a sudden here rolls a rain cloud, which happens very often in Florida, and unfortunately, maybe some of that pesticide got run off because it had just been applied. It hadn't had time to seep into the soil or into the leaf surface, whatever, to where it runs off into, say, that spring or that nearby lake or pond, and that's going to contaminate that surface water. Another way of contaminating surface water is by eroded sediment. Now, if we think about this in terms of maybe some soil that's already been contaminated, and we get a really big rainfall, and we've got some really heavy downward flow of some water heading down a hill, it's pulling with it some soil that could be contaminated, and then it ends up in the lake or pond that's there at the bottom of the hill.
But how does that? What does that have to do with a pesticide applicator?
Well, that kind of goes back to a lot of what we've been talking about here. Is that something that sticks around in the soil? Could that soil be holding a large amount of pesticides in it to where now it's being displaced from the farm into this water source?
But I wanna go back and contextualize my question. If we are unnecessarily treating areas that have a slope, we might be investing a lot of pesticide in that area that we shouldn't, and as a secondary effect, there's no root mass holding that water, and then you create an erosion problem. So those things you got to keep in mind. It's not part of the book, but it's common sense.
Right. It just goes along with being a responsible pesticide applicator.
Yes.
Sure. And then second, not only with the surface water, but we have our groundwater. And 62% of our freshwater use comes from this groundwater sources. And most of that is going to be the Floridan aquifer, which is far below ground in some areas of Florida. It reaches closer to the surface than other areas. And what we worry about there is going to be leaching of pesticides through the soil profile. And so that's going to go into what, like Luis was talking about, solubility. If it dissolves well in the soil water that we have, it can leach readily through that profile and potentially reach that groundwater. So a lot of how our pesticides can reach groundwater are dependent on the different soil properties, and that changes throughout the state. So we have different soils that are on the ridge versus the flatwoods versus coastal areas.
Okay. So talking about properties of that soil, can we elaborate on the properties? Why are they important?
Yeah, so the properties of soil are really important because that's how the pesticide is going to move around in the soil, right? So we need to know what soil texture is, what organic matter is, depth of groundwater, and geology in order to understand how ultimately, if the pesticide is not applied correctly, it's going to end up or it may end up in groundwater. So basically, the texture, which is the first term here, refers to the distribution of the different particles of soil. So here we can talk about sand, silt, and clay particles. So basically, clay particles are the smallest ones of all the three that I mentioned, and sand are going to be the larger ones. So when you have sandy soils, which in Florida we have a very large percentage of sandy soils, you don't really have that much of nutrient holding capacity or water holding capacity on the soil. So that facilitates leaching, and a lot of your pesticide could end up in groundwater if you have like sandy soils.
And the other thing about clay soils is that they expand with water.
Yes.
So they block, they create layers.
Exactly.
And the water slows down.
Exactly.
With that sandy particle.
Yeah.
You don't have that property, so the water just flows through.
Yeah, the clay particles have more of an absorption capacity, so they hold that water better. So organic matter is basically the decaying plant material. So if the organic matter content in the soil is high, the water and nutrient holding capacity will be greater, as I just explained. The depth of groundwater, areas with a shallow water table will have a higher chance of groundwater contamination. So this happens because there are less soil particles for the pesticides to adhere to.
So it doesn't filter through.
It doesn't, exactly. And then the geology refers to the permeability of the soil. The highly permeable materials will allow the movement of water and pesticides, which also could facilitate leaching.
And then we do have in Florida some cavernous areas that, with karst topography, and with that, it creates the potential to transport a lot of water in a short period of time. We have sinkholes that are created readily, and we hear about them in the news pretty regularly. So that geology encompasses everything like that.
Right.
Okay. In conclusion, we have to understand what we are doing, where we are doing it, and what our impact may be with that pesticide application. This is why it is important for us to study the situation before we start applying. There are consequences to a faulty thought process, which is pretty normal, but knowing what to do and the characteristics of that pesticide can help us address some of the issues and avoid further contamination if we incur in something like that. Contact your local extension agent. We can help you, again, understand your soil, understand your pesticide by helping you guide you through that label, and then giving you more information on your environment. So remember, we're here for you. This is the conclusion of chapter 5, and this is the right dose. See you next time.
The brands and trade names mentioned in this episode were used with the intention of education and not for marketing or advertisement. IFAS Extension is an equal opportunity institution.